Hello everyone, welcome back to the GIS software video series. Today we're going to see the John Snow problem. Basically, John Snow was the inventor who first invented the concept of GIS. So today we'll see how he calculated the cholera of his area. So using kernel density. So here are some data he used in his problem. So here is the attribute such as palms, cholera deaths, map. In this time, if you go to the attribute table of cholera death, you can see the count ID. Also, if you go to the palm, we can see their attribute table. John Snow identified the palm and the cholera deaths of a specified area. So we have to first run the IDW to see if the which area is more affected. So we go to search, we will search IDW. Here it is, we click on it. So we have to identify the death across the area. So input the cholera death, and the Z value will be the count, and we'll save it. Save, and others will be default, and we hit OK. So the IDW is done. Now IDW is not sufficient to see the density around the deaths. So we will use a new function which is kernel density, which John Snow used in his techniques. So we'll search kernel density. Here it is. We click on it. We input the cholera death, and the population field will be count, and we'll save it somewhere. It will kernel.tif. Hit save, and we hit OK. So if you can see the kernel density is done, if you go to its properties and change the symbology, we will give this color. Okay. So from the kernel density, we can see which area is more affected from the cholera deaths, which area has the higher density. But if we see the IDW method, we can't see the density where uh, which area is more affected by cholera death. So this is the difference between IDW and kernel density. So in this case, the kernel density is more sufficient. And also, if you untick the cholera death, we can see the pump location of that area. So from this, we can see which pump location has the has the influence for causing death. So we can see that this pump location has the most influence for causing cholera death. So this is that's how John Snow identified these pumps. Now we're gonna see another thing, which is time variated data. So how we can get that data? This data is not inputted by normal normal data, so we have to put it by a new method. So we're gonna search net CDF. So which is the format of the time related data. So we will take this make net CDF raster layer. We take it, and now we're going to input the file, which is the we'll make the time variated data. So we're going to input this file, which is the time variation data. We're going to open it, and now we're going to give the variable, which is input variable will be pr. The x dimension will be x. The y dimension will be y, and we're going to hit OK. So this is the time related data which change over time. So how we can see that, we go to the properties, and if you see here, we will see a net CDF format. So the dimension time and the value, we can change the value from time to time. So if you change the date, the map is changing. So if you change the again, the map is again changing. So this is the time related data which changes over time by time to make it looking more visibly good. So we go to display and we change it to bilinear interpolation. So the data looks more visibly clear. So from this time related data, we can change different datas. We can change it time to time, so we can see a different map over time. Now we'll see another type of data, which is the nighttime data. So we gonna open a new data frame and we're gonna input the nighttime clip. We're gonna add it. So this is the nighttime clip of a certain area. So the black part shows that this is a rural area and the white part shows that there is light. So this is the urban area. So from this data, we can see that how we can manipulate the urban area in this certain area. So for to do that, we go to search and we'll search ISO. Here we'll select the ISO cluster unsupervised classification. So basically, it classifies a area based on different features. So if you input the nighttime clip and if you paste the number of classes 5, we want 5 classes from this image, and we save it to night time 1.tips. We save and we okay. So we can see that the urban area of this certain area has been changed. But if we see see the data frame, we can see that we have given it 5 classes, but it is only 3 classes because it is unable to create 5 classes. And so the unsupervised classification had made it 3 classes. And if you give it to see it more clear, if we go again to the ISO cluster unsupervised classification, we're going to give the nighttime clip again, and if this time we'll give the number of classes to 10, and the output classified will be nighttime 2.tips. We hit save and okay. So in this time we have given 10 classes, but it has taken only 6 classes. So it is also unable to take 10 classes. That's why it created only 6 classes. So what can we do from this? The urban area is changing by this classification, and we can manipulate this data by this classification. So that's for all today. Thank you everyone. See you on the next video.